Hello, my friends. In this video, we are going to apply what we have learned in a previous video to solve the problem of AC circuits. And in this example, which is a typical AC circuit, we are going to find the Thevenin equivalent circuits. And given that the output is uh, A and B terminals. Uh, just like any other AC circuits, we have capacitor and inductors. We also have AC voltage source and current source. And our job is to find the Thevenin equivalent circuit for this circuit. And as I already told you in the last video, we can apply Ohm's law for the AC circuit. And we can do that in much the same way as we do for the DC circuit with only resistors. Uh, Now, to begin with, right, the first step is to open circuit, terminal A and B. So we are going to do it now. Open circuit, this is the first step. A and B. So step one is um, open circuit A and B. So answer, open circuit A and B. And find the Thevenin voltage. So this is the first step. And how are we going to find it? The circuit is very complicated, but it isn't complicated at all. All you need to do is to do a trick. Now we have a common point here. Let's label this point as node X. And the voltage at this point is going to be V of X. And now with this information, then we can find the total current. Now let's assume the current flowing in this one, in this branch is I1. And the current flowing in this branch is I2. And the current flowing in this branch is I3. And by Kirchhoff's voltage, by Kirchhoff's current law, by Kirchhoff's current law at node X. Sorry, node X. We have the sum of current I1 plus I2 plus I3 being equals to 0. And in this case, we can say that, right? 20, what is I1? 20 minus Vx divided by A. And what is I2? I2 is already given. And what is I3? I3 is going to be, you can use VA minus Vx, but this is complicated. If you do that, then the equation end up with two variables, two unknowns. Uh, so how about this one? No way. We don't know the voltage here. How about this one? No, we can't do it either. We don't know the voltage here. How about here? Oh, yes. We know the voltage here at this point. The voltage here is 20. So why don't we do this? 20 minus Vx again. But this time it will be the total impedance around this loop, around this pathway. And the total impedance here is 1 minus 3j and then plus 2j and then plus 4. And the total current is going to be 0. And if you do it carefully, then you will end up with Vx uh, equals to 18.5 minus J 0.4. So this is the value of Vx you are going to get. But now the answer is not Vx. The, our objective is not to find Vx. Our objective is to find VA, the voltage at this point. The voltage at this point is VT, the Thevenin voltage. And how are we going to find it? We can do that, right? We can find what is I free. I free in this situation is the sum of this column, this whole expression is I free. So 20 minus Vx 1 minus J3 plus J2 plus 4. And we can also express I3 as Vt minus Vx. And then the bottom is going to be 1 minus J3. I'm now talking about the impedance between Vx and Vt. And if we do it very carefully, then you will end up with Vt being equals to 27, and the angle is going to be 20.2. Now you have got the Thevenin voltage. How about the step two? The step two is to zero all the sources and then find the impedance across AB. So step two, zero all sources, all the sources. And find the impedance AB, find ZT. And according to what we have got here, if we do that, right, we will sort the voltage source here. Then we will get a straight pathway here. And if we open circuit, this circuit, and you end up with nothing across here. So this is what we are going to get for solving the impedance. So right now, it is very obvious. The impedance is going to be the parallel of this, the impedance of these two pathways. So I would say, right, ZT is going to be 4 plus J2, and then in parallel with A plus 1 minus Vj. And if you do it very carefully, then you should end up with an impedance. And the impedance is given by minus 1.84 minus J 0.93. And do I have enough space here? Yes, just enough. So this is going to be the Thevenin impedance, and this is going to be the Thevenin voltage. The final answer, if I'm going to erase the space here, free up some space here, yeah? Then what we are going to get is the equivalent circuit. The equivalent circuit is going to be 27 and the impedance here is going to be minus 1.84 0. Again, this is A and B. So this is the answer. This circuit is equivalent to this Thevenin equivalent circuit. And the circuit is very simple. You have an AC voltage source here with the amplitude 27 volt and with the phase shift minus 20.2 degree. And the source impedance of this circuit is going to be minus 1.84 minus J times 0.97, and the unit is ohm. Okay. So if you have any questions, please leave your question to the comment section. Thank you very, very much for your time. Bye-bye.